We're talking about angles, and angles is basically where we are going to start talking about geometry for our year. And you might notice that none of these pictures are of geometry or angles or anything. In fact, this is the sport of cricket. I don't really understand cricket. I don't know if this guy's called a pitcher. I don't think he's called a catcher. I don't know what this guy's doing here, and he's gonna try and hit it, I think. I think this might be called a wicket. Maybe that's an umpire, referee. Maybe he's got a different name. What's this guy doing here? They got three purple guys right here. So anyway, why am I talking about this? Oh, also, this is the thing that they're hitting and that they hit with. It looks kind of fun, but whatever. And there's also a reason why there's a board game here. If we were going to try and play these immediately, if we were going to try and talk about angles immediately, if I was going to ask you to solve and do stuff, you might go, but what are these things? I can't really talk about them until I've defined what I'm talking about. So that's what we're going to do is basically, I'm going to start by saying, hey, listen, here are some famous angles. There's a 45-degree angle. There's a 90-degree angle, 180 degrees. I guess we could go ahead and go with 270, even though I didn't do it in class. And then there's 360 degrees. There are other famous angles, but this is just where I'm going to start. And what I'm going to do is basically draw a line and start by saying that a straight line, maybe I should draw a straight line. Let's get the line drawing tool out. Here we go, straight line. At that straight line, I'm going to put arrows on either end. And this is an example of 180 degrees. This is a straight angle. That is one way we would call it. So the reason I mention that is if, again, you're playing cricket or baseball or Risk or whatever sport, there might be more than one way to name something. So this is a straight angle. It's 180 degrees. And if you're wondering how that gets measured, I'm going to temporarily put in that you would start basically from here and go and travel until you reach over here, and that is traveling 180 degrees, okay? So I'm going to erase that for now. That's 180. And now what I'm going to do is I'm actually going to put a dot somewhere close to the middle. That's close enough. And I'm going to draw a line straight up. You might recognize that this is 90 degrees. So what I'm also going to do is make this direction. I'm going to make him blue also, so that we're kind of focused on this thing right here. This is a right angle. It's 90 degrees. And if you're wondering why is this called a right angle, why do we put that little boxy thing in there, is because if you think of a rectangle, a square, basically any quadrilateral, this area right in here, that's the 90-degree angle. And notice how square it is, right? So that's why we have that in our little angle thing down here. Next, so I guess I should say, hey, did you notice that this was 180 and it did travel in an arc, right? We saw this arc like this, and then I got rid of it, right? So let's get rid of it again. And what happened is now we're only traveling in this arc. So it's like we cut it in half, right? And that's because that's exactly what we did if we cut that in half. Now, what if we cut it in half again? Hopefully you see that that would be a 45-degree angle. So I'm going to cut that in half. And there's that line and this line. And I'm going to draw this little arc-looking thing. Now, if you're like, wait, you've been drawing arcs this whole time. You're right. I've been drawing stuff like, oh, why is it not doing it? Hang on. Let's try it again. It's been doing stuff like this, right? Well, so that little one right here, this little green one, the green arc that I've just drawn, that is us being specific, communicating about this angle right here between these two, okay? This blue one is talking about between these two, and we usually don't put the straight angle arc because it's just a straight line, okay? Now, one thing that people were just really excited to tell me about 45 degrees is that it is acute, which means that it is less than 90 degrees. less than 90 degrees. And then something else that people were like, oh my gosh, did you know that this 180, it's obtuse because it is greater than 90 degrees. Okay. And if you're like, okay, we have, how many vocab things do we have on the table at this point? We have 1, 2, 3, 4, 5. If you're starting to feel overwhelmed, honestly, all of these things are angles. So I think you're going to be okay with that. Acute, one way we can remember that is things are acute if they're little and small, and they've got to be smaller than 90. Things are obtuse. In fact, when I say the word obtuse, I don't feel like I say it quickly. Acute. I can say that really quickly. Obtuse. Maybe I say obtuse quickly, or can. But anyway, my point is when I say the word obtuse, I feel like I'm saying a larger, longer, bigger word, even though it's not a real big word. So that kind of helps you to think, oh, it must be bigger. Yeah, it's bigger than 90. Okay? Right angles. Dude, you've known right angles for a while, so hopefully that's not new to you. If it is new to you, it's in squares and rectangles, and that's the little square rectangle. And straight angle, it's straight. So you just have to figure out a way to make straight 180. And if you could use a little bit of help, I tend to think of like where I've heard 180 like in real life, and I think of like skateboarding, and that's you just turn halfway around. I don't know. If you need a little bit of help, we can try and figure that out for you. Okay, so now here's what's going on. We traveled all the way over, and then we kind of backtracked half and backtracked another half. What if we kept going and then we went maybe further? Well, here's what it will look like if we went 270. So here's 45, 90, 180, 270. That is 270 right there, and I'm actually going to erase this so I'm going to draw that yellow line. I'm going to draw this yellow line, and you might be like, oh, wait, is that a right angle right there? Hang on. Let's not talk about that being a right angle. Let's talk about 270 is this big yellow arc, okay? 270 is a large angle, right? That's what we're describing. Yes, now the other part of it is 90. But anyway, I'm not going to keep that one there. And I'm really not going to write anything down about 270 because he doesn't have like a fun name that I'm aware of. And last but not least is the 360. Okay, now, if you don't know what 360 is, I feel like you've been living under a rock, but 360 is all the way around, dude. It's a circle, basically, okay? So I'm going to go ahead and leave that little purple circle up there, okay? And I'm going to get my purple color changed here and draw a circle 360. It's all the way around, okay? So now what I'm going to do is kind of zoom out and jump over here and go underneath angle. And what I'm going to do is I'm going to draw an angle, just a random angle, and it's going to look like this. And if you're like, is that 45? Don't worry about it. That's not what we're trying to worry about. What I'm going to do here is define angle. It is 2 rays. Stop. Do you know what a ray is? The way that I think of rays is I think of the sun. In fact, I should have made that yellow to begin with. And the sun is sunshine, right? And it sends out these rays of sunshine, right? Is the sun receiving its sunshine? No, it is only ever sending out rays of sunshine, right? So a ray is like, it begins and it goes out forever. It's 2 rays that have a common, and I'm going to try and write this in a different color for a reason, they have a common vertex. Do you know what a vertex is in this situation? It's the sun. So these 2 green rays form an angle right here, and what is making up that angle is the 2 rays, and they have a common vertex, which is this point of origin right here, okay? Now, we can also name angles. Oh, you know what? Here's one other thing. In class, we had to learn the word ray. And so let me make some comparisons of, okay, a ray looks like this. This is a ray. We have a line. And if you're like, wait, a line, didn't we draw a line over here? Yeah, we did, and it had arrows on either end, right? That's a line. And then last, how about a line segment? MENT. So what's the difference between these? Well, a ray has a vertex, a starting point, and it goes forever. Do you notice any dots on this? No. Can it have dots on it? Yes. But it does go on forever in either direction. A line segment, this is something you carry around in your pocket. It's a pen. It has a start point and end point. You can't carry around a line. You can't carry around a ray, but you can carry around a line segment. So there is kind of that little part right there. Now let's do some naming of some angles. So let's start simple. And I'm going to draw this angle right here. What I'm going to do is I'm going to label the vertex, and I'm going to give it a couple more points. And I'm going to label it A, B, C. Here is how you officially name an angle. So naming an angle. Here we go. You draw this little symbol. It looks like a less than symbol, right? But it's an angle symbol, I promise. And we're going to call this angle A, B, C. So here's what we've just done, in case you missed it. We technically just gave directions that, hey, we've got an angle. And we're going to start at point A, go to B, end at C. And hopefully you see that that describes this arc right here, this angle, the opening of those two rays. There is another way we could have written this. Let's try that out. We could just call it angle CBA, because we could start here at C, go down to B, slide over to A, and now we have just described this angle right here. It's the same, right? I just happen to follow the directions in reverse. So that's how you name an angle. One thing I love to point out about this is that the vertex is in the middle. And that's just how angles work. The vertex is in the middle. Like our vertexes over here were all right there, right? Our vertex right here was the sun. Let me give them some cool guy shades. Very cool, Mr. Sun. Get a smiley face. Go for a thumbs up. Yeah. Okay, that's a bad thumbs up. Moving on. Something else I ask students to point out is, what do you notice is the same or different about these? And they're like, well, what's different is they're backwards. And yeah, they are backwards, but it was because we can travel in reverse and get the same angle. So now we've named one. Now that we've named one, here comes a challenge. So you can pause the video and try this on your own if you'd like. There are numerous angles here, okay? I want you to try and name a handful. Let's just go with 3. Try and name 3 different angles. And if you're not sure what I mean by naming them, just remember this back over here, okay? So pause the video. Okay, so I went above and beyond and I wrote 4. Ooh, scary, okay. HKJ, angle HKJ would be from here to here to here. It's this angle. PKM is from here to here to here. It's this angle. LKM, LKM, it's this angle. And then PKL, the reason I went with a 4th one is, check this out. PKL. PKL. Well, that's this angle, right? So what's kind of fun about that for me is this angle is equal to angle PKM plus angle LKM, right? if you took this angle and you added that angle, you'd get that whole angle, right? And if you're like, no, I don't see it. Well, I mean, imagine I had this white angle and I was to break it into two pieces. I might have this green piece and I might have this red piece, right? So that's what I mean. So there are other angles that we could have named. We could have gone crazy with it. We could have named a straight angle. In fact, here, why don't we name a straight angle? Angle HKL, here, here, and here. So hopefully you learned from this that to name these things, to name them, you need 3 letters. And the middle is the vertex. And in fact, I didn't say it, but maybe I should say it. Look at all of these, 1, 2, 3, 4, 5 different angles. What's in the middle? K, each time, because K was the vertex, right? So now I'm immediately going to break the rules, because here are 3 angles. There's no arguing that these are angles because they fit the definition: array, a vertex, array. They share that vertex. Same thing, right? I don't have 3 letters. And if you're thinking, well, you got 3 angles, that's 3 letters. No. Here's what I'm saying. We could call this red one angle J. You could get away with that. That's allowed. The yellow one we could call angle M. The blue one we could call angle R. The reason that you're able to get away with that is because it's not like this, okay? If it's like this, if I were to go up here and say, all right, y'all, talk to me about angle K, what are you going to do? Are you going to describe this angle? Are you going to describe this angle, this one, this one, this one? That's where you kind of have to use some common sense. And sorry that, common sense and math class might not always mix, but hopefully you see a difference here in when you're able to use one letter. In fact, I like that so much I wrote it down. When can I use one letter? When it looks like these, okay? When it's more obvious, when it's more common sense looking. Okay, so I want to zoom out so you can kind of see where we've been, and now where we're going is here. We're going to be going to adjacent angles, complementary angles, supplementary angles, vertical angles. And I'm actually going to stop this video here because one of the things I really like to do is ask students, once they figure out, once I kind of teach them what complementary and supplementary are, and even adjacent vertical, I like to say, hey, how would you remember this? Because I can give you my definitions all day. In fact, that's kind of what we do is we go from, hey, what is the actual definition to how can you remember it? So I've had some good ones throughout the years. I'm going to wait to ask you. And maybe if you know somebody who plays cricket, they can explain it a little bit to me, and I'll explain a little bit about angles to them. And I'll see you at the next video. See ya.